Hey, hi all. This is Abhishek. I work as a technical architect with a leading organization. I have deep expertise in Microsoft .NET, Azure Cloud Platform as a Service, artificial intelligence, intelligent automation, and machine learning. Also, I have a very good experience in robotics process automation, and I have worked for a couple of years in this area where I have helped two major banks automate their processes and helped them build bots that gave a very good full-time employee savings. So, okay, that was about me. Let's now get into the topic, robotics process automation. Before we get into robotics process automation, let us try to understand what software automation is. This very word or jargon automation is nothing new in the software industry. It has been there from decades. Okay, so let's try to define what software automation is. Software automation is the science of building code that either replaces or augments day-to-day tasks performed by software engineers. Okay, so what are the different tasks performed by software engineers? A software engineer, or in a broader sense, a software professional, can do a lot of variety of things in his day-to-day activities. Few of them would be gathering the requirements, doing a project planning, having an architecture ready, doing a design for a module or rather for the project, writing code for a module or for the project, doing testing of the module or the project, doing the deployment of the project, having the infrastructure ready where he would be deploying his code, doing a code review, and the list is long. So, these all activities that are performed by software engineers can be automated using the techniques of software automation. Okay, and I'm pretty sure you must all be familiar with all these automation softwares. Like we have for test automation, we have QTP, we have project management automation softwares, requirement gathering automation softwares, and so on. We will touch in depth in the next slide. Okay, in today's context, software automation is not just about handling repetitive tasks. Automation code that we build nowadays, they can be intelligent. They can have machine learning capabilities. They can gather more insights about a task or the activities that a person is performing. And thus, they can help in automating more complex processes.
Software automation techniques helps in reducing human efforts and increases its efficiency. It reduces the time to make software deliverables market ready. So what I mean by this is, when the organization is implementing software automation techniques, its employees can be more productive, they can be more efficient, and it can quickly build products that can hit the market faster, and this will give the organization a competitive edge. Okay, so now software automation is everywhere. Maybe requirements capturing, maybe software architecture designing, software project planning, test case automations. Like I can give a very good example of test case automation software is QTP or a load runner, software code generation. So whenever we work on any project, so we build different layers in the project. For example, we can have a business layer, a data layer, a API layer, a user interface layer, and so on. There are automation softwares available that can take minimum inputs from the developers, and they can help in generating code snippets for each of these layers. So as a result, the developers can quickly create the software code for the project, and the project can be released faster to the market. Software automation can be used for infrastructure planning and commissioning. It can use for software build generation. The best example is the TFS builds from Microsoft. It can help in automating software deployment processes. The best example of software deployment automation is Octopus Deploy. It's a great tool to help you automate deployments. Finally, it can also automate end-client processes, and this is what robotics process automation does. Before we try to understand what robotics process automation is, let us try to understand what we mean by the word process. A process is a task that a business process executive or a back office staff performs for an organization. Okay, so let us take an example of a process. A bank has a very good customer base. The customers need not come to the bank. The bank has laid down a process that whenever a banking customer needs a bank statement or a statement of its account, it can drop a note or an email to the bank. So in the bank, a BPO executive or a back process executive will read through that email, raise a ticket, get the statement generated, get it signed from the required authorities, and mail it back to the customer. So this is a process that is happening. Like a customer has requested for a bank statement and the bank is furnishing it the statement. So using robotics process automation, this whole process that is being performed by the business process executive of the bank is getting automated. We will see a lot of more examples in our coming slides. Okay, so now let us define what do we mean by a robotics process automation. It is the art of building digital workforce that can comprise of software bots that augments to human workforce of an organization. What that means is organization can employ developers who can build software bots that can perform the tasks of the business process executives of that organization. Both the business process executives and these software bots can work hand in hand and complement each other to deliver efficiently, and the organization can achieve the results at a very faster rate when it employs bots to work hand in hand with humans. These bots can be intelligent enough to think like humans with the help of artificial intelligence and machine learning capabilities. They can offload human to do more meaningful work and can take up the mundane task performed by them that they may not be interested to do. These bots save cost for the organization, and the costs spared can be used in more meaningful initiatives like research and development of a future product or in some branding and marketing strategies and so on. It reduces or minimizes human errors in the transactions. They are nothing but software code pieces or like software artifacts that are programmed to do a particular thing. So hence there are no chance of errors that we can find. Bots work around the clock, and this gives the human employees in an organization a work-life balance. Let us discuss about the maturity model for the robotics process automation. So any software product matures over time. As and when time passes and it progresses in time, so more and more features are built into the product, and as a result the product becomes more matured. And same is the case in robotics process automation. There are three distinct stages in robotics process automation, that is a do stage, a think stage, and learn stage. Now let's talk about what they do. In the do stage, bots perform just the repetitive tasks. They are programmed to do a certain thing. They don't have any intelligence. They cannot think. They are just programmed on logics, and based on the conditions and logics in the program, they behave. They simply do what they are asked to do. They do not use their brains. In fact, they don't have brains. So these are the do bots, or the first generation of the bots. In the second generation of the bots, we have the think bots. These bots can apply intelligence and they can think and then execute a task. Whenever a task is assigned to this category of bots, they do think like humans and then they execute it or perform it. They can understand the intent of the customer or extract meaning out of the images and more of such scenarios. They are capable of taking decisions, and they are not programmed to take decisions based on condition. Based on their capability, their thinking ability, they can take the decisions. Bot developers normally use intelligent services like Microsoft Cognitive Services or IBM Watson along with RPA tools to make bots intelligent. But nowadays, these bot softwares like Automation Anywhere or maybe Work Fusion, they all come with these intelligent capabilities. Now let us talk about the bots that can learn. They can incorporate machine learning in their day-to-day tasks. They can learn from their past activities and can perform their current tasks. For these bots to be successful, there has to be a lot of data available so that they can perform a machine learning activity on it. These bots can learn from past transactions and data and perform actions accordingly. Usually, bot developers use machine learning models along with RPA tools to build such bots. Now, let us talk about few use cases in robotics process automation. Let us talk about a banking scenario. A banking customer can request for a swift transaction or a historical statement or status details, maybe through a mail or a portal. So what these bots can do is they can simply monitor the mailbox for these requests. Once a mail hits the mailbox, these bots can read the mail and raise a request for the approval. And all such things in banking world goes through a maker checker process where the bot will create a request, and that is a maker, it will make a request, and there would be an approver bot that can do the checker process, like it will go through all the policies and check the validity of the request, and if the request is valid then it will give the approval. And once the checker process is done, then the bot can fetch the bank statement and send it back to the customer. So instead of process executive doing all these things, now we can see that the bot is performing these activities. Now let us see another example from the retail world. A retail giant employs a software bot to manage customer feedback. What these bots can do is they can monitor the feedback in the mailbox or in the social media sites like Facebook or in Twitter or so on. They will analyze the feedback and think on the feedback, and based on the past data availability they can do some kind of machine learning, and then they can suggest some corrective actions to the company. For example, if there is any negative feedback, they can come back with what can be done to improve it. And all these informations the bot can suggest only when it has a very good amount of past data available with it and it has the think ability to perform on that data. And once the corrective action has been suggested to the company and the company has taken the corrective action, it will communicate back to the customer who had raised the feedback. Now let us take another use case. A food outlet employs a software bot to help customer order its food. The customer can chat with the bot and place the order. Bot can study past orders of the customer and can understand its ordering pattern. Based on his past ordering pattern, it can provide some suggestions proactively that will help customer decide on the order. It can provide or present the menu to the customer, and once the customer places the order, it can note the order and place it with the food outlet. And it can also provide a real-time tracking status to the customer when the order is getting prepared or it's in the way to the delivery. Now let us see the step-by-step process that is used to build robotics process automation solutions. So while building a robotics process automation solution, it goes through different stages. First, the opportunity is identified. That is, what part of the business can be automated and who can be automated. what exactly it means is which is the process that can be taken up from automation. Not all processes that can qualify for the automation. There is a list of criteria that it has to fill to, and this is currently the out of scope of this presentation. Maybe in some future video I'll come back with what are the criteria to select a automation process. Once the opportunity is identified, then an assessment is done. In the assessment, we check what to automate and what to not to automate. Then we come up with a percentage. Say like we have a process, out of that we can automate 80% of the process and 20% can still be a manual activity. So opportunity is identified, the process experts or the domain experts in an organization who are actually the business process guys, and they do their day-to-day activities and they understand the process or the business very well. And the assessment is done both by the process experts as well as the automation solution architect, because he's the technical guy who is going to take forward this process for automation. And once we have decided like what to automate and what not to automate, then comes the requirements gathering phase. In this phase, the process expert, the process owner, the person who is the business stakeholder of the process and is managing the process and is responsible for the process, and the solution architect, all of these three come and sit together and they do the requirement gathering. Then the solution architect takes this forward and designs an RPA solution. Once the RPA solution is ready, the development team comes into picture. It writes the code for the bot, they test the bot and they deploy the bot. Next comes the go live and the education process for the users and the process executors. So it's the responsibility of the process expert, RPA solution expert, and the process owners to educate all those process executive guys who are actually executing the processes on how to deal with this bot and what things this bot will be performing and what are the manual steps that these process executors will be performing. So it's a very crucial steps. So once this is done, then comes the bot monitoring phase, where the process executors and the bot monitoring team will get a handover and they will monitor the bots. Now let us talk about RPA bot infrastructure design. In this design, we have a control server from where all the bots are controlled. These bots can be monitored, they can be assigned with tasks, they can be assigned with a task queue. So all these activities can be done on the control server. And these bots are client softwares that run on client machines. They can either be a virtual machine, they can be an on-premises system, or they can also be on virtual machines on cloud. So basically the control server hosts the bot control software that controls the individual bot systems. Bot softwares can be hosted on cloud machines, as we hinted on earlier. It can be on company virtual machines and on-premises systems. All the bot health and the execution details are available in the bot control software that sits on the control server. Control servers are usually load balanced and of course they are access controlled. Not all can access into the control servers. There would be administrators who will have the permission to control the bots. Usually the administrative permission is given to the process executives who are going to control the bots. Now let us talk about the software that can be used to build the bots. Any of the scripting languages like VBScript, Excel macros, JavaScript, PowerShell can be used to build bots. No need of having any expensive tools. With the simple scripts, we can build the bots. We can use any high-level language like C# or any other programming language like R, Python to build a bot. We can also use vendor automation softwares like Automation Anywhere, Blue Prism, UiPath, WorkFusion to build bots. But trust me, in the real-time scenario, it is usually a combination of all above to build a bot. And all these tools support using any of the scripts or a C# program to build a bot. So the tool means what I am intending is this tools like Automation Anywhere, Blue Prism or UiPath or any other automation vendor provided software tools. They all support the scripts and high level languages. Okay, so finally we have come to the end of the presentation, and I will just pass on the last words is like when we are automating, let's do social automation. Automation should not harm anyone. It should not replace the bread and butter of someone, but rather bot and human should work hand in hand, and they will make the organization for which they are working more productive, and they should not be replacing human. And with this last note, let's close this presentation. Hope you all enjoyed this presentation. Thanks for being patient with me.